Alright, so in this question we have been asked that suppose there's a 2 cross 2 matrix X which is not necessarily Hermitian nor unitary, and it is written as X is equal to A0 plus sigma dot A, where the matrices sigma are the poly matrices and A0 and A1 comma 2 comma 3 are numbers. How are A0 and AK, where k is equal to 1 comma 2 comma 3, are related to the trace of x and the trace of sigma k x? And in the second part we have to obtain A0 and AK in terms of the matrix elements of xi ij. Alright, so firstly, what have we been given? We have been given that X is a 2 cross 2 matrix. So they have given the expression of X as A naught plus sigma dot some A. So here the sigma is a 2 cross 2 matrix, and A is just a number. So, and since there is no matrix here, we have to assume that there's a 2 cross 2 identity matrix here. So if we write the X in the matrix representation, what do we get? Let's see. So we have A naught and there's a identity matrix here plus sigma times A. So sigma can be written as sigma x, sigma 1 and sigma 2 and sigma 3, x cap, I cap, j cap, or whatever. It's in the three directions. These are the three components of sigma. These are the poly matrices. So sigma 1, which is essentially sigma x, is given by 1 0 0 1. Similarly, sigma 2, which is sigma y, which is given by 0 minus I and 0. Sigma 3, which is sigma z, is given by 1 comma 0 0 minus 1. So these are our poly matrices, and the vector A can be written as A1 plus A2 plus A3, where these are the three components of A. So now if we take a dot product and add them all up, so sigma dot A would be A1 sigma 1 plus A2 sigma 2 plus A3 sigma 3, right? So what do we get? We have sigma 1 is just 1 comma 1 0 0 1. So we get A1 0 0 A1 plus, here we'll get 0 minus IA2 IA2 0 plus A3 A3 0 0 and minus A3, right? Okay, here's a mistake I have made. The sigma 1 matrix is not 1 0 0 1, it is actually 0 1 1 0. I'm sorry for that. So here this matrix would be 0 A1 A1 0. So now if we add all these matrices, we get the following. We get A3 A1 minus IA2 A1 plus IA2 and minus A3, which is our value of sigma dot A. Then again we have another element which is A naught I, and I is just the identity matrix of 2 cross 2 order, which is given by 1 0 and 0 1. So this will be A naught 0 0 A naught, right? Alright, so if we see X now, X should be equal to the addition of those two matrices. So it will be A naught plus A3 a1 minus ia2, a1 plus ia2, and a0 minus a3. So this is our X matrix, which is a 2 cross 2 matrix. Now we have to see what is the trace of X. So if we try to find the trace of X, so a trace of the matrix is the sum of its diagonal elements, and by diagonal I mean this diagonal. So let's see what is the sum. So you can see the sum of the diagonal elements is just a0 plus a3 plus a0 minus a3, which will just give us 2a0. So we get a0 is 1 by 2 times trace of X. This is the result we got, because in the second part they have told us to obtain a0 and ak in terms of the matrix elements of xij. So this will be useful, this will come in handy. So they have also asked in the first part ki how are a0 and ak related to the trace of X and the trace of sigma k and X. So this is the first answer we got, that a0 is related to the trace of X by a factor of half. Alright, so the next one we have to find the trace of sigma k X. So what is sigma k X? So sigma k, where k is been given as equal to 1, 2, 3. So sigma can be either 1 times x, or sigma can be either 2 times x, or sigma can be either 3 times x. Let's try calculating all these three and see what if we can get a pattern or something. So sigma 1 x is just, so sigma 1 was 0, 1, 1, 0, and we got x as a0 plus a3, a1 plus ia2, a1 minus ia2, and a0 minus a3. So let's multiply these matrices. Let's see what we get. Sigma 1 x. So let's see what do we get. So let's add this up. So we get a1 plus ia2, and then here we have a0 minus a3, then we have a0 plus a3, and then we have a1 minus, right, a1 minus ia2. Yeah, so if we take the trace of sigma 1 x, we'll have a1 plus ia2 plus a1 minus ia2, which will just give us 2a1. So we can see that a1 is equals to the trace, half of the trace of sigma 1 x. Similarly, let's check for a2 and a3 also. So sigma 2x would just give us 0 minus I 0 times a0 plus a3, a1 plus ia2, a1 minus ia2, and a0 minus a3. Excuse me. So sigma 2x, here we'll get, let's see what we'll get. So we get minus I a1 plus a2, then we have a0 minus I a0 minus plus I a3, and then we have IA0 plus IA3, and we have IA1 and plus A2. So this is what we get. So if we take the trace of this matrix, we get minus IA1 plus A2 plus IA1 plus A2. So these two terms cancel and we get 2A2. So A2 is just half of the trace of sigma 2x. So you can see a pattern, right? That A2, whenever there's a A2 here, we get a sigma 2 over here. Similarly, we got a A1 here and a sigma 1 here and multiplied with a half factor. We'll get the similar case for A3 is equal to trace of half of trace of sigma 3x. You can verify this result yourself. We will get this result. So we can write that AK will be equal to half of trace of sigma k x. So this is how they are related. AK and the trace of sigma kx are related by a factor of half. And similarly for A0, it is related to the trace of x with a factor of half. Now they have asked in the second question कि obtain A0 and AK in terms of the matrix element xij. So I'll write x here again. X is A0 plus A3, A1 minus IA2, A1 plus IA2, and A0 minus A3. So we can express this as matrix elements of x like x11, x12, x21, and x22. Right? So now we have to obtain A0 and AK in terms of the matrix elements of xij. So A0 is just half of trace of x, and the trace of x would be just half of x11 plus x22. So this is the result for A0, that is half of x11 plus x22 in terms of the matrix elements of xij. Similarly, we have to do for the for the A1s, A2s, and A3s. So for A1, we have to consider sigma 1 x, which is 0 1 1 0, and we have x11, x12, x21, and x22. So we'll get the resulting matrix as x21, x22, x11, and x12. So we get A1 as half of the trace of sigma 1x as we discussed before. So the trace of this matrix would be half of x12 plus x21. Just give me a moment, I'll connect my charger because it's running on low power. Alright, miss it. Similarly for A2, you can calculate it for the trace of sigma 2x. We'll get this result, which is half of x minus of x21 plus x12, and for A3 we'll get the result trace of sigma 3x, which is half of x11 minus x22. So this would be our answer.